Welcome to another version of Math Inc. Today we're going to talk about Newton's generalized binomial theorem, which in short terms can be written like that. And I'm sure it could be a bit scary if you don't know what all that means, but we're going to talk you through it. I'm just going to start with an example. Let's say you have a plus b to the 0, and a plus b would be different from 0. So that would be equal to 1, because anything to the 0 power is equal to 1. A plus b to the 1 power, or to 1, is just a plus b, which is easy. A plus b squared is equal to a squared plus 2ab plus b squared. I'm sure you've all seen these formulas before. A plus b to the third power, or cube, is a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, we could go on for this like ever, but the way this was calculated was by taking a plus b squared to get a plus b cubed. I did a plus b squared and I multiplied that times a plus b. So, if I wanted to calculate, let's say, a plus b to the 73, I would need to calculate all the other ones before it, and that would take probably a couple of days before I could even get close. So, to do that faster, I'm going to talk about, let's say, what are called combinations. Let's say I have the first case, a plus b squared, and I'm going to write it like this, because I have this squared. So, I'm going to multiply this times this, this times this, this times this, and this times this. In other words, how many ways can I get, let's say, a squared? I can only do it one way, because I can only take a from this side and a from this side, and that would be a squared. Now, how many times can I have a b? I can take an a from this side and a b from this side, that would be a b. Or I could take a b from this side and an a from this side, that would also make an ab. So I have two ways. That's why it's 2ab. And the last is how many ways can I make b squared? Well, I can only do it one way if I take a b from both sides. That would be b squared. Now, that same way, how many ways, if I have a plus b, so it would be a plus b cubed, can I get an a cubed? That would only be one way by making a plus a times a times a. Now, how many times can I make a squared b? Because you're going to have all the powers of a and all the powers of b, so we have to do it in order. So that way I could do it by taking an a from here, an a from here, and a b from here, 1, an a from here, a b from here, and an a from here, 2, or an a and a b from here, an a from here, a from here. So it would be something like a, b, a, or b, a. So that, all that would equal to a squared b, and I have three different ways. That same thing would apply if I wanted to make a times b squared, which is the next term. I could take a b from here, and a from here, a b, or a, b. And the last b cubed, I would only make it from one way, for b cubed, b, and b. So as you can see, if I have, let's say, to the 4th power, I'm not going to go through the whole series, and I wanted to know, let's say, how many times can I get a squared b squared? Well, all you have to do is look at the combinations. If I have, let's say, I'm just going to look at in how many ways can I get a, because if I don't get a, I'm going to get b. So, you see that as a combination of, you have n terms, but you want to know how many times that k is, how many times you want to get the term, which in this case is n. But I'm going to explain this combination formula in just a second. Before that, we're going to look at Pascal's triangle, which is written in blue right here. It is made, or it is constructed by adding the terms from above onto the below terms and putting ones to the side. So that 2 is actually made from 1 plus 1, and let's say this a plus b squared, you have 1, 2, 1, which are the coefficients of the expansion. When you have this to the third power, you have 1, 3, 3, 1. Those are your coefficients that you're looking at. So in general, Pascal's triangle works. But again, if I wanted to calculate, so this would be like 0, 1, 2, 3, and that in green is the power, because when you have power 0, it's just a 1. Nope, that is your only coefficient. So in general, let's say I wanted to calculate again a plus b to the 73, and I wanted to know the coefficients. If I do it with this method, I would also do a Pascal's triangle that would go up to the 73rd level, and that would also take me a very long time. So there must be still a better way. But before that, we're going to see what this means in combination ways. That 2 could be represented in how many ways by just going in diagonal lines. Can I reach that 2? Well, I can reach it if I go from here to here, or that would be one way, or if I go from here to here. That's 2 ways. In general, all of these are 1s because the only way to get here is by going all through the end. Because if in any moment I decide to go inside, I can no longer go outside due to the algorithm or the rules I just explained. So you can see Pascal's triangle is how many ways can I get to a certain point. And since you know, let's say you know that you can get to 2 different ways right here, and you know that you can only get to 1 way right here, well, the way to get to this point is the addition of those both ways. Now, the combinations that I was trying to explain earlier, which is n and k, and the formula is n factorial divided by n minus k factorial, k factorial. And you know that n times factorial would be like 1 times 2 times 3 times 4 times 5 times 6 times 7, all the way to n. So this little formula practically gives you the number in Pascal's triangle. So if I wanted to rewrite Pascal's triangle with factorial, or in that notation, all I needed to do is write 0 and 0. This would be 1 and 0, 1 and 1, 2 and 0, 2 and 1, 2 and 2, and like that. I mean, that's 3. So that is the same way as Pascal's triangle, because that is like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on and so on. So writing this notation is just giving you the notation for the coefficient, and that is what's written in here, the coefficient. And all you have to do is, how many ways can I get an n, an a, which is n minus I, and when you don't get an a, you get a b. That's why b is just an I, and that is the sum from I to starting at 0 all the way to n. And that's the formula you have, and you can use. Thank you.